Find the derivative of f of t equals the square root of 3t squared minus 4t plus 5. Then evaluate f prime of negative 2. F of t here is the square root of an entire expression, 3t squared minus 4t plus 5. The first thing we want to do is rewrite the square root into a fractional exponent to help with the derivative. So 3t squared minus 4t plus 5. It's to the first power, but then it's the second root. First power, second root, 1 over 2, 1/2 power. The derivative, f prime of t, will be done by the power rule, since the outer function is the 1/2 power. Bring that power down. Leave the inside alone exactly as we see it. Subtract 1 from the power, 1/2 minus 2/2. I'll call it 2/2 so we can subtract it with a common denominator. But then, since the inside of the 1/2 power isn't just a t, it's an entire expression, we have to multiply by the derivative of the inside, since it won't be just a 1, but something more than a 1. The first term, 3t squared, will become 2 times 3, 6, t to the first. The negative 4t derivative will be the constant negative 4, and then the 5 will have a derivative of 0, so 6t minus 4. This is multiplying the entire expression. That's the chain rule. It's the derivative of the inside expression in a power function or a trig function. Since everything is multiplied here, I can move the 6t minus 4 over with the 1/2. And I will have 3t squared minus 4t plus 5 to the 1 minus 2, which is negative 1 over 2. Now, the negative exponent means it can move to the denominator and have a positive exponent. And that means it'll move down with the 2 that's already in the denominator. The 6t minus 4 will stay in the numerator. There's a 2 in the denominator from the 1/2. And then we will have the 3t squared minus 4t plus 5 to the positive 1/2. Now the 6t minus 4 in the numerator actually has a common factor of a 2 that can factor out. We'll maybe want to do that because it will be able to cancel with the 2 that's in the denominator. So it'll be 2 times 3t minus 2, all of this over 2 times 3t squared minus 4t plus 5, all raised to the 1/2 power. The 2's can cancel. One more step, the denominator, since it's the 1/2 power, first power, second root, square root. That means we have the square root of 3t squared minus 4t plus 5. And there's our derivative f prime of t. Our next step is to evaluate f prime of negative 2. That means to plug in negative 2 in for each of the t's. So we will have 3 times negative 2 minus 2 divided by the square root of 3 times negative 2 squared minus 4 times negative 2, and then plus 5. In the numerator, 3 times negative 2 is a negative 6, and then minus 2, all over the square root of 3 times negative 2 squared, which is a positive 4. A negative 4 times a negative 2 is a positive 8, and then plus 5. In the numerator, we have negative 6 minus 2, which is a negative 8. In the denominator, we have the square root of 3 times 4, which is a 12. And then an 8 added to a 5 is a 13. So we end up with a negative 8 over the square root of 12 plus 13 is a 25. 25 is a perfect square. We have negative 8 over the square root of 25, which is a 5. 8 and 5 can't reduce any further. Negative 8 over 5.